Hello, everyone. Justin here with the Gear Priority Podcast, and I hope you're ready to get slightly nerdy. Today, we're talking about how sleeping pads are tested for warmth using the RValue standard and diving deep into how the standard came to be, what goes into increasing warmth of a sleeping pad, and ultimately how and when you can trust RValue numbers to be reflective of real-world performance. I'm joined by Brandon Bowers with Therm-a-Rest. Most of you probably have heard of Therm-a-Rest before. They make popular sleeping pads like the X-Lite and X-Therm. Brandon has a background in industrial engineering and has been working with Therm-a-Rest for almost 25 years, so a long time. And I believe he was also involved in the working group that developed the ASTM sleeping pad RValue standard that we widely use today. Hello, Brandon. Welcome. And where are you calling in from today?
Hello, Justin. I'm calling in from our Seattle building here in downtown South Seattle.
Okay, and that's the headquarters of Therm-a-Rest,
correct? Yep.
Awesome. So you get, I've seen some videos with some pretty cool toys like the cold chamber. Is that where you guys also have an RValue testing machine over there as well?
Got a number of things for testing all of our gear in, Therm-a-Rest specific, but then all the other brands as well.
That's cool. I've looked at all the testing facilities with a lot of jealousy. I'd like to one day. My goal is to create get a warehouse and just pump it full of have cold rooms and humidity rooms and also wind tunnels, all sorts of testing facilities just to do some of that testing myself. And so glad you're here. Like I said, we're gonna be talking about RValue today. I like to start things off with some rapid fire questions. So the first one: what are your top 2 favorite outdoor activities?
Oh man, being on the water and beachcombing, and then exploring for chasing a waterfall or something. Yeah, those 2 things.
And this is kind of a random one, but I threw it in here just to see what you might come out with. But what is your favorite law of thermodynamics?
Oh, that's a tough one. I only know of number 2, which is that everything's going to, entropy, I think. Second law of thermodynamics.
I think that's the one. I think the first one is you can't create or destroy energy. So yeah, we'll go with number 2. I think that's a good answer. Are you a cat or a dog person?
I'm a hybrid. It hasn't existed yet. Yeah, it's a cat dog.
And what's the favorite product that you've helped bring to market at Cascade Designs / Therm-a-Rest?
Probably our current Mondo King, TriCore Mondo King.
That's the more like car camping geared sleeping pad.
4-inch thick, stretch top with special cut foam so that it's a little softer and packs lighter.
It's crazy the technology that has been put into some sleeping pads and how comfortable they get. I sometimes sleep better out on trail or in my tent than I do at home.
I believe it. Yep.
All right. So let's jump right into it. I think RValue and standardized performance measurements for gear, it's important because they help consumers make informed decisions on what to buy and how that purchase is going to perform for them out in the field. That being said, while standards are great, it's important to understand how the testing happens and what the limitations are. But before we kind of get into all of that, can you help us understand what RValue is? Maybe some of the definitions, some of the history, and maybe some of the non-outdoor applications that may have stemmed RValue to be used for sleeping pads.
So what RValue is, it's a measure of heat transfer or lack thereof. So it's really the insulation properties of a product or a material to diminish heat transfer from one side to the other. So really what it is, it's insulation, a way to gauge an insulative barrier. I honestly don't have the dimensions in my head for the true engineer. But RValue, the test that was used very early on in Therm-a-Rest was the ASTM method for testing walls. So in the construction world, you would look at how you're going to design a wall to hold out the cold. And if anyone's ever insulated their house or pulled off the inner covering of their wall, you'll see this a lot of times it's filled with all kinds of materials. And oftentimes, if you're using appropriate materials, it'll have an R on it. So you can go and buy insulation and it'll just say R5 or R13. And it's essentially the same idea.
Okay. And I think I heard somewhere that like the R stands for resistance. Is that, if that's correct? Like the resistance of.
It's possible, but I can't say that for sure. I mean, it is, you could argue that's what it's doing. It's resisting heat transfer. But then if you got into the electrical terms, that's a different thing. So I think it might just be one of those numbers dedicated to it, right? It like science does.
Mm-hmm. And do you know when the outdoor industry started using the RValue standard?
So I'll speak from the Therm-a-Rest point of view. We first established a way of measuring RValue in-house in around 96. We have documentation of that. And then we started using that to advertise. I believe within a couple years, we were putting that on our packaging. What other companies were doing at that point, I can't say if there were other companies doing some formal measurement.
My guess is that Therm-a-Rest is probably at the forefront doing something like that. I think it's always been one of the kind of champions and pioneers of innovation and testing. And not to to toot the Therm-a-Rest horn too much or anything, but that's just kind of been my experience with it. And I think it's interesting that Therm-a-Rest is also part of the working group that developed the new ASTM standard. So you had mentioned the ASTM standard that is used for construction and housing in order to measure that insulation. And it sounds like there's kind of a modified version of that was used in the outdoor industry for sleeping pads. But then in 2020, we had the release of the new ASTM standard that's geared towards sleeping pads. Can you explain kind of why that new standard was needed and kind of what changed towards the old way of testing?
Around 2016, I believe the ASTM group formed, and it was led by MEC, so Mountain Equipment Co-op in Canada. A lot of times at shows like the outdoor industry has the OR show in the summer. That's usually a good annual meeting spot for different working test groups such as tents. So this one was formed, and I believe there was some overlap with the tent group, and then that's where this group started meeting at least, once annually. But there were often lots of emails flying throughout the year. The reason it formed is MEC, and then in the US, REI, purchase these brands to sell. They would buy them from us and then sell them to their customers, as well as developing their own products. And they were, in my opinion, the best voice to come in and realize and call attention to there was no good standard and that there needed to be, just for a customer to make an informed decision and to level the playing field. I believe that, from my understanding, that's how the group formed. And then they reached out to the many different key brands, and then, pretty much all brands, for the most part, were involved in that work. If not, every meeting they were checking in, as it went.
Yeah, that's interesting. I think if I'm getting my facts correct, REI and MEC now require all sleeping pad manufacturers that they carry to have tested their pads with the new RValue standard in order for them to carry them, which is just good. Like you said, for the consumer knows that everything's kind of being tested the same way and is on the same playing field. I know from personal experience, I remember using sleeping pads that it was everyone was kind of maybe using a different testing standard, and I'd use one sleeping pad in the field that had an R value of 3 and I'd be warm, and then I'd use another sleeping pad that had an R value of 3 and I'd be cold while I was out there. And it seemed like after the new standard came about, there's some shifting in those numbers, and things kind of made a little bit more sense. That's not to say that I don't still see some interesting discrepancies in R value out there, but we'll kind of talk about that a little bit later. So now that we have this new R value testing standard, can you just run us through what that entails? Like what sort of equipment's involved, and how the sleeping pad is being tested by companies like Therm-a-Rest? I know you guys have your own machine, but then I think REI and Mac have their own as well.
Yep. A lot of companies have invested in it. And then there are some international testing companies that have also invested in it in Asia. So what the ASTM method did is it, number one, defined the procedure, which then by nature defines your essential equipment or what the equipment needs to do. So what you do is you're trying to simulate a person laying on a mattress against a cold surface, and that it defines that so we have a hot plate simulating body. We have the location and how to treat your test specimen, and then you have a cold plate and its temperature and what size it should be, and then finally in the test environment, like your air temperature, etc., it defines that. And then we're talking about a program, and there is an application to your test and how it's supposed to take readings to eventually get what you're measuring is temperatures, and you're looking at how much energy it takes to keep the hot plate hot, because you're losing, a well-insulated product. You're going to take less energy to keep your hot plate hot than you would on a very poor insulating material. So it's all about using electricity and the flow of electricity to keep the product hot, and then converting that to power. So so hopefully that wasn't too much in the weeds, but essentially it is still very much mimicking what happens. Your warm body is being protected by the cold surface with the product, and how well does it protect it?
Okay, so you're creating a sandwich. Like you have this hot plate, and then you have the sleeping pad, and then you have the cold plate, which is the ground, and you just sandwich them together and kind of measure how much energy is being lost to that cold plate from the hot plate. Okay, interesting. Yeah, it was.
And as you hinted at, there's different methods in our discussion before, there's different ways you can lose heat. There's conduction, convection, and radiation. And so the hot wants to go to the cold. It's a part of science, right? And so it's reliant on that. One other thing I wanted to mention, so that's the equipment. Also, there was a good amount of work in how you condition your product, and then if the product doesn't quite fit, like the certain size that the product has to be. For instance, if you had a super narrow product, you would possibly need to make just a test product for the R value. I would say in most cases that doesn't happen.
So are most companies, for most testing, is it happening on like a 20-inch wide sleeping pad, or would testing happen on a 25-inch wide sleeping pad? Is that width?
20 inches is acceptable, so 20 to 25. And then you talk about the shape, so that if you have a shaped product, then there has to be a minimum. Don't quote me, it might be like 18 inches of width, if let's say that it's really curved. That's where it would come into. You might have to make your own not true product so that it was big enough. But it will accommodate up to 25 inches. So you're looking at 20 to 25 inches, no problem. And then the other thing is that it tests in 3 different regions of your mattress. And part of that is because we now have mattresses with different insulations at different points of the mattress. And then just some basic science of you have to provide 3 separate samples, and then you test those in 3 separate places and do an average. So there's a lot of details in there that inevitably cause everybody's RValue to adjust a little bit. One of the things that was significant for us is our air pads. My predecessor always wanted to deflate them slightly to about 80-90% of thickness. Well, this standard holds the pressure internal of all air holding specimens to like 0.5 psi, which means you're going to test to a full height, and that increased our RValue on all of our air mattresses. So
that makes sense. And what popped into my mind when I was thinking about that is if I was a manufacturer, I mean, maybe I'm mistaken in how the system would be affected by this, but I'd probably want to limit all external surface area that's around those 2 plates, because if that's exposed to the air, then there's a chance that that's just colder temperature that's influencing that whole system. Is that so? Do companies try and do that?
It is true, and it is an effect. So again, don't take my word for the Bible here on this, but I believe the actual test device has a 12 by 12 inch plate surrounded by a 20 by 20 inch guard. So it does help make up for the different sizes and also heights. So with air mattresses, it is an effect that you are going to lose more air out the side the higher the product is, unless you were to construct it in a way that warm air travel couldn't escape out the sides. I don't know of a product that's doing that yet for air products. Foam naturally does, you have to travel through the foam any which way, and it's insulative. But air pads, yes, the thicker they are, the more heat you're going to lose out the sides, as well as through the bottom and the cold ground.
Yeah, and I think that's something that I've been seeing is as we've kind of, even since 2020 when the new standard came out, we've seen a bit of an arms race in sleeping pad thickness, where some are hitting like 4.5, 5 inches thick. And it's a little bit crazy, unnecessary. For me, unnecessary, because just the way I sleep, even as a side sleeper, I find like 2.5, 3.5 inches kind of the nice sweet spot. And then I have noticed with some sleeping pad technologies and the way they're built, that a lot of cold air is coming in the sides, and there's not effective convective heat loss prevention, I'm guessing, in order to prevent that cold air from getting in the sides and cooling me off. It's more geared towards that. The insulation's geared more towards kind of an up and down system, which is what the RValue is testing, than as much in from the sides. So that was an interesting thing that I noticed. And I am curious, when Therm-a-Rest, because you guys had your own machine, RValue testing machine before, did you have to make any changes to it when the new standard came into play, or is it?
We invested in a new machine. So ours was different enough, and the other thing is that ours was somewhat not portable, and the new system was portable, which was important, just as places of work change or you need to move a lab. So it was worth the investment for us. Yeah.
Cool. Yeah, that's good to know, because I kind of thought maybe it was different, but interesting to hear that it's kind of like a different enough machine. And how long did you guys have that older machine? Because I imagine technology has probably also changed.
Yeah, since '96. So we invested in it 96. Now, the company that we worked with is the company that we bought the new machine from. So the main difference, I'd say, I'm sure the technology, well, I actually don't understand the sensing technology that the company's called Therm-a-Rest uses, but the fundamental difference from our original system to this new system is that we controlled the ambient air to create the cold environment. So we had a guarded hot plate, and then the ambient and the cold plate were the same. Okay, so the new system used the guarded hot plate, an actively cooled cold plate, and then basically like 68 degree, 20 degrees C ambient air, which you could use in like a standard lab environment. So that honestly is easier too, because we used our cold chamber to actively cool the big cold plate, and is a little bit more cumbersome. In summer, our freezer would freeze up, and we'd have to wait for it to thaw. So, because it was basically a big air conditioner or a refrigerator. I mean,
when you guys were when you were part of the standard development team, were there any challenges that came about, or any butting heads? And I imagine if there's stakeholders from a bunch of different places, then everyone would be kind of lobbying potentially for their technology to be maybe a little bit biased or was it?
I didn't feel or observe much of that at all. And to me, what I did observe is people, this group, as I would say, a lot of the people I've worked with over 24 years in the outdoor industry, it's a good industry to work in. Like, people, I haven't worked outside of it too much, but the integrity seems pretty high from what you might expect, and meaning like just in general at someone's working place. So no, I think people worked, their ammunition or their belief was like, I want the truth, and then we're going to make the best one. And so that part of it is always, it's one reason I've loved working in the outdoor industry.
Was it mostly engineers and designers that were on the team, like kept the marketers?
Yeah, no, there wasn't really, no, it was technical minded people wanting to get to, as accurately as possible to make a test that represented what the product does.
That makes sense that there is just kind of a single, everyone was kind of on the same page and driving towards the same goal in that sense, because that's more just about the science than anything else. So I want to kind of dive into a little bit more of the technical aspects of kind of linking sleeping pad design to the RValue testing, and how those two things kind of work together, before kind of jumping into a little bit maybe the limitations of RValue testing, because I think this will kind of set us up for that. I know, based on kind of my I have a little bit of a science background, and just enough to kind of be dangerous, but the heat transfer mechanisms that I remember are convection, that radiation, and then conduction, kind of those three being the main ones that are probably influencing sleeping pad insulation. And I know, can you speak just maybe a little bit, just for an example, as far as like a lot of people are familiar with the Therm-a-Rest X-Lite sleeping pad. There's a few different technologies in there that are kind of targeting one or two or three of those different things.
I'll actually take it a little bit further back. So when Therm-a-Rest was founded in like early, I think it's 72, the whole thing there was people were using either closed cell foam, which is bulky but light, and it is still very much, when you think of foam, it's a bunch of cells with little thin walls of plastic. So they'd use that, or they'd use like a blow-up pool float or heavy-duty blow-up pool float, so it wouldn't pop on you. So the pool floats were more cushiony, but they were not insulative. They're just basically you had one layer of air between you and the ground. Whereas the closed cell foam, you actually had millions of little cells, but it wasn't that thick. So, so when Therm-a-Rest was created, it had one of these like multiple levels of benefit. So number one, you could putting a valve on it, using the foam as a spring and rolling the air out and closing it made it easy to carry. And then using that foam to draw in the air, also that foam was cushiony for extra comfort. And then finally, the open cell foam created, again, thousands of little cells of pockets, which are basically layers of air to stop heat transfer. So foam is really one of the like most common insulators. It's in like fiberglass insulation is in a way doing the same thing. It's just interrupting that ability for heat to travel. And then also, so you have the convection of air wanting to circulate, but you also have a material that doesn't like to transfer heat anyway, which is similar to like electricity. So metal likes to transfer heat. If anyone who's grabbed a hot pan, not realizing that the handle started to heat up, like, oh, but you put wood on the handle, the wood doesn't like to transfer heat as much. And then we know like fiberglass, certain materials really don't transfer heat well. So foam would be a really good insulator always. We kind of know that. So then when you get into our fancy products like our X-Lite and X-Therm, what we did is what I would say is you're going to have more success when an air product is able to create more cells, which sounds a lot like foam. So our air product structure created extra air cells so that you had the convection blocking with just the air cells. But then we also added in the reflective layers that addressed the radiative loss of heat so that your body heat actually the radiative layer reflects your heat back to you also. And radiative heat loss is something that I had to learn about more, and I still don't feel confident talking about it as a science person, but that it is different than convection and conduction. So it is infrared energy that it's electromagnetic energy that gets transferred. I do think you need to address all three if possible. Within a mattress, for the most part, convection heat loss is less of an issue. So it's probably more conduction and radiative. Air does move, though. We toss and turn, but the whole system, the whole mattress is enclosed. So when you get into systems, you start talking about what a closed loop is, and then it's sort of up to you to figure out if it's a closed loop or not, because inside of a tent, for sure, it's a closed loop for the most part, right?
Okay, that's interesting, because I think something that I've noticed is it seems like the more structure there is inside of the sleeping pad, which I imagine is what's helping with convective heat transfer, the more efficient it becomes, especially as the pad gets thicker. Like that, that's anecdotally something that I've noticed while out there, and I think maybe that's because of heat coming in from the sides, like because I think in the real world, like we talked about, we have that sandwich of like someone on top, sleeping pad, and then the cold ground beneath. But then when you start introducing cold from the sides, then you kind of need to prevent that as well. Is that what the goal of the triangular core matrix and the X-Lite X-Therm?
I wouldn't say it was trying to address that, but the TriCore Matrix does create an extra layer that the air needs to fight through as you heat heat air up or transfer. Yeah, you're heating the air layer up, so then it might start creating a little convective circle, um, but it can't go through that middle layer that is there. So then, as even earlier, I'm like, well, I said convection isn't as important. It's part of it inside the little system. So yeah, I would say I don't want to. I've made a living, working in this industry, but there's still some like it's a head scratcher. It's like, okay, what's exactly going on here? And then really that's, what you might do, and we've done it before, is with these RValue, the RValue equipment, is you can test your theories and change one thing and say, well, what does this do to the RValue?
Do you have any are you able to talk about any of those examples of some tweaks that you guys have made to kind of see what might happen and then what the results were?
I think it would not be wise of me to describe that. I'd just say that when you do, and it's not, now at this point, all companies have that ability. They can make up different samples and then try them, right? When you have your own equipment, you can turn that around faster maybe, or be able to just say, oh, well, what if you can just tweak the experiment faster. Yeah.
Just I just want to kind of jump into something that we used to see, but now don't really, and that's temperature, like a temperature rating being attributed to a sleeping pad. And I'm kind of curious as to why that might, from kind of your perspective, why that might not be the best way to test it. Like why RValue is a kind of a better standard.
Perfect. Yeah. First of all, a temperature rating, giving an actual Celsius or Fahrenheit temperature, was discussed in the ASTM meeting as creating a scale or something of that nature. The number one, it sort of went beyond the scope that the ASTM group felt, and I was in agreement with that myself. So then the question was, well, do we work to have sort of do we have a market encompassing scale? And that really did not come. The ASTM working group that had a bunch of different brands represented didn't feel that was necessary. The challenge of using a temperature like an actual number one, is that we all sleep different. And what is warm enough for you is not going to be the same for your mother or your wife or your daughter or your son. So it was a really nice way, I feel like, to say, okay, this RValue is a scientific measurement. And then that way we can give the customer a very repeatable number. And the way I would describe to anybody is you just need to get some experience under your belt and be cautious initially, and buy something that would, you ask your friends, you ask around, you kind of aim a little bit more cautious if you're an avid outdoors person, but new to it, and then get a little bit more adventurous with it. So so that's one reason why the industry really doesn't give solid numbers in temperature. The other reason is that the ground you're sleeping on and how it's insulative is a big part of this. So a great example would be, you could sleep on a glacier in the summer. So the glacier is ice, but the air temperature might be 50 degrees. So what temperature are we saying? That's just a quick example of that.
That makes a lot of sense, and I've definitely experienced that, where I've been sleeping on semi-frozen ground in the springtime. Maybe the air temperature is 20 degrees Celsius. I think that's around like 70 degrees Fahrenheit. But then I need something with a much higher RValue than maybe at the same air temperature, but in the fall, like late summer or fall, where the ground is thawed, maybe holding on to quite a bit more heat from during the day. It's a completely different kind of environment. But I guess I guess so it makes sense to me that air temperature and that's the RValue testing system is kind of a good example of why air temperature isn't really the best measurements. You have that cold ground, you have a person, and then you have the insulating pad in between you. So that's I know some companies that like I think a lot of companies these days they have some sort of guide to.
Yeah, we use that one. We still use a guide, but we've tried our best to not use definitive numbers, so to speak, and to give sort of a guideline and make it clear that this is a guideline, not, a scientific number. So
That and I think that's it. You can generally correlate that something in the 70s, 80s, 90s, and is going to be a warmer. You're gonna have a warmer experience even with the ground compared to something in like below freezing. So I think it's good for especially people like you said if they're buying their first sleeping pad, then probably a good idea to err on the side of caution within those recommendation limits, but and then work their way down and I always encourage people to rent gear.
yeah, that's a good way to do it. Yeah, and I do. Interestingly, I've over the years it sort of dawned on me a good way to ask people is like what we've all had difficult sleeping experiences from just having to crash at a friend's house in a bad environment or bad bed to being outdoors. And it's for the most part, I would say people's like worst or close to their worst sleeping nights are more about that they were cold versus uncomfortable. Now, that might not be the case for a person, but it's something to keep in mind. Which would you rather have? Would you rather be colder than you thought, or would you rather be, just keep that in mind? So it is an interesting way because we tend to think we're more worried about being comfortable. So we think of that cushion. I need something really cushy. But it's just another way to look at it that is dawned on even myself. On the flip side, part of that can be the adventure for some of us. Some of us can say, you know what, I'm gonna go out with we have an Uber light, right? And so some of us have used the Uber light when it's, in the shoulder seasons and just seeing how it goes. And maybe you bring extra clothes or something. So it is fun. And I would say people who get into it realize sort of they customize their system on how they're going to sleep, and in that experience, they learn how it works for them. I do know some of our folks use a really warm pad more year round and then just plan on, maybe they don't take a 20-degree bag that time, they take a lighter bag.
Yeah, like you said, everyone's personal preferences are different. I know people who sleep on a thin closed cell foam pad in the cold shoulder seasons, and they're completely okay. And it also has to do a little bit with like campsite selection, and so many different factors. And it's crazy how much trial and error can go into just going on a camping or backpacking trip.
That's an important one too, is even campsite selection. I've learned through scout, like my son was in scouts too, about how cold air will pool in valleys. So if you're like right at the bottom of a valley, it's going to get coldest there quick. Stuff like that.
When putting together the new standard, I think like it was interesting to hear you kind of mentioned that having the room as kind of a standardized factor was, I think you said that was a new part of the 2020 standard. Did you guys look at how different things like humidity and that kind of thing might factor or impact the testing as it happened? Like, was there any testing as far as like something like if the room was 100% humidity versus like 20% relative humidity?
I'm not recalling that test. It might have happened. I think it was more focused on just temperature. And again, part of it that we were all keeping in mind was trying to make a standard that was, we'll say, more easily repeatable for a lab, to invest in. So one challenge there would be if you did want to do this test, if you did hold a higher than normal humid environment, then that you're like, okay, now someone needs to control their humid environment. So if they did look at it, I would be surprised if it moved the bar much, but that was one thing that we considered. We're like, we don't want some system that's really hard to achieve, because then the industry is going to be hard to adopt it. So that was taken into consideration.
Were there any other, I don't want to call them like trade-offs necessarily, but considerations that were made to make the testing system easier, but maybe wasn't accounting for something that may be impacting an RValue number?
I'm trying to think. I do know our closed cell pads took a hit, and part of that was that our compression of the closed cell pad in the Therm-a-Rest earlier version, like at pre-2016, was less than this current system. So the new system compressed closed cell more, which reduced its RValue. And it's not unreasonable how much it compresses it, but I do think it might give a little bit less reading of what the closed cell pads actually do for you, or at least molded closed cell pads.
So by molded, you mean like the accordion style ones, like that have like the divots and
anything with ridges that can collapse a little bit when you lay on it. So the whole thing comes down to, well, what's that? A body's laying on a product, and you have these different pressure points. So it, like at your shoulder blades, it collapses the product a little bit more, or a mattress, you sink into it a little bit more. So with closed cell, I would say it adversely affected closed cell the most. So our old standard was higher, and then this new standard was lower. And when we say standard, I think it's important to note, pre-2020, there was no standard. It was all self-imposed, and how a company advertised their RValue or insulative ability.
Okay, that's a good point. So just kind of build off that. So when people, because like we talked about how RValue is kind of like a comparison measure that people can use. Should they be looking at like self-inflating versus air-filled versus closed-cell foam as three separate pools of data, I guess, for RValue? Like you can't really, like, would you say you can compare like a closed-cell foam pad RValue? It'd be comparable to like a air mattress inflated? Okay.
Yes, I would say that this test does exactly that. That's exactly what this did. I think there was some question as to like, do air products behave differently? It's like, no. So and I would say we found that to be true as well, just for people using the products and hearing like what they're willing to take for cold weather, in air versus foam over the years. So,
okay, that's good to know, because I think some people might think that they would be comparable, but I guess it's all measuring the same thing out there, right? So,
well, so the one thing I would say for air, and I explained it earlier, that we were testing our air pads a little bit underinflated. So the pressure in the pad was probably, like maybe 1/10 of a PSI. So if a person really likes a flat air pad, which, there's always outliers. So it seems a little unusual to me, but if you like air pads and you like to sleep on them underinflated, they are going to be colder than advertised, from my experience.
And that's a good point. I don't think a lot of people realize that. And I've told people, like, I've told a lot of people that where they've come to me and said, for example, like their X-Therm wasn't as warm as they thought it was going to be. And from personal experience, it's a very, very warm sleeping pad. But I asked them, like, what inflation level did you have? And they said, well, I was like, I deflated until my hip and shoulders were just above the ground. And I told them, like, that's probably why you're not maximizing that resistance, like that temperature gradient, and insulation there. So.
Yeah. And again, this is one of those things. It's like, in a perfect world, right? You could easily like have a little kiosk wherever someone buys things and you could explain to them this, but, yeah, if you're touching the ground, you're helping conduction, so, and you can just, most of us who spent enough time on that, you're like, oh, like I can feel that cold on my hip, so if you were in a survival mode, pump that air mattress up as hard as you can.
Well, that's great. I really appreciate the in-depth conversation. I think we dove deep into some cool aspects of RValue, the testing system. I think we're gonna wrap things up now. I definitely want to probably have another conversation at some point about kind of the limitations of RValue, but we'll save that for another episode. But any closing thoughts on RValue and the testing?
The one thing I would say, if anyone's really interested in it, I reiterate that it is a personal thing and what you like. And if you geek out about that sort of thing, that can be part of the fun. Also, sharing, like you said, sharing equipment and checking with other people is part of the fun too. Hey, how did this work out for you? That really builds the best understanding, in my opinion, along with the knowledge like this.
Definitely. And I think it's important to get a background of the science and then like get the testing out there. That's one of my kind of, what I see, one of my purposes is as a gear review tester on YouTube is to be testing lots of different gear. I think I tested over 40 different sleeping pads out in the real world under kind of as standard conditions as I can get, and trying to share that information with people. So very interesting. Thank you very much, Brandon. And we will talk to you later.